Hello colleagues, in this discussion we are going to be looking at how we can solve a problem requiring us to determine branch currents using mesh current analysis and superposition theorem. But of course this circuit is a unique one since it involves AC sources. So this is an AC circuit that has impedances instead of only resistances. So let's go ahead and use mesh analysis. So this is what we are going to begin with, mesh analysis. So let's assume we have a mesh current I1 and a mesh current I2 in this branch. So using KVL, you know KVL states that any potential voltage drops within a closed loop will always sum to 0. So if I have 10 volts at an angle 0 degrees minus, I will be of course subtracting since there is a voltage drop across these impedances. So minus, we shall have a 5 I1. Remember, if this is coming a plus minus, this is also a plus minus. So what is going to happen here? We shall also have minus 5 I2. Yes, so this I1 continues this side, so we'll have also minus I1 into 3 minus J4. So the whole thing is equal to 0. So what is this going to be? I can take these ones the other side so that I have, I'm going to have 5 plus 3, okay, minus J4 into I1, then plus 5I2, this is going to be 10 at an angle 0. This is going to give us 8 minus J4, I1 plus 5I2 equaling to 10 at an angle 0 degrees. So what would this mean? 10 at an angle of 0 degrees is the same as 10 into cos of 0 plus j sine of 0 degrees. Cos 0 is 1, so this is sine 0 is 0, so the whole thing will give us 10. So meaning our first equation will be 8 minus j4 I1 plus 5I2. This is going to give us 10. This is our first equation. Let's consider mesh 2. Consider mesh 2. If I consider mesh 2, what is this going to be? Mesh 2 is going to be, I'm going to consider now the voltage drops from this 20 volts source going throughout the other branch. So we have 20 at an angle 0 degrees minus the current this side is I2 times 3 plus J4. Yes. Then obviously we shall have minus 5 I2 then minus 5 I1, and this is equal to 0. So this is going to be 20, obviously this is going to be 20 volts will be equivalent to, so I look at this and that. So this is going to be 8 plus J4, and this is I2, then plus 5 I1. So I rearrange, I'll have 5 I1 plus 8 plus J4 I2, and this is 20. So I solve the two equations simultaneously. Now, if I consider the first equation and the second, I can use what we call Cramer's rule. So using Cramer's rule, let's solve 1 and 2 simultaneously. So first of all, we will have a matrix that is formed. So this is 8J4, then we have 5, then we have 5 here, and 8 plus J4 into I1, I2. And this is equivalent to, we have 10 and 20. So I'm going to pick this matrix. So I look for the determinant of this matrix, D, which is for matrix J4, 5, 5, 8 plus J4. So if we don't know how to solve simultaneous equations using Cramer's rule, I'm going to share a video whose link I already have. So remember to check in the description for this particular discussion. So this is going to equal to, obviously, I'm going to multiply the major diagonals, then the elements in the major diagonal, I subtract by the product of elements in the minor diagonal. So I'll have 8 minus J4 into 8 plus J4 minus 25. So remember, this is like multiplication of a complex number and its conjugate. So this becomes 64 plus 16 minus 25. Is this 80 minus 25? This should give us 55. If this is 55, we are going to proceed and look for D1. So D1 is a determinant of a matrix in which the coefficients of I1 have been removed and replaced with the outputs. So I will have D1, which is 10, 20 with the 5 and 8 plus J4. The coefficients for I2 remain there. So this is going to be 10 times 8 plus J4. Then we subtract 20 times 5. So this is obviously going to give us negative. This is going to give us negative 20, then plus 40J. So what is D2? D2 will be the determinant of a matrix in which the coefficients of I2 have been replaced with the outputs, but maintaining the coefficients for I1. So I will have 8 minus J4, then I will have 5, I will have 10 and 20. So this means I will have 8 minus J4, I multiply by 20, I minus 50. So what would D2 become? This is becoming 110 minus 80J. So if I want to get I1 will be D1 divided by D. So I1 equal to negative 20 plus 40I or J divided by D, which is 55. So this is giving us our I which is going to be negative 0.364 and plus 0.727J. So the output can also be 0.813 at an angle of 116.57 degrees, and this is in amperes. So what is I2? Let's proceed to get I2. So I2 will be D2 divided by D, and we said D2 is 110 minus 80J divided by 55, and this is equal to 2 minus J 1.455. You can also convert it so that you have I2 equivalent to 2.473 at an angle of negative 36 degrees. So using mesh analysis, we have been able to determine the currents in the branches. On the left branch, we have their I1, and then the right branch, we have their I2. So if someone asked you the current produced by the 10 volt source, then it would be I1. The current produced by the 20 volt source would be I2. And when you look carefully, you see that I2 is greater. I2 is greater, obviously it is coming from a greater or a bigger source. And I1 is smaller because it is coming from a smaller source. So we are going to look at superposition in the next video. Thank you.